Hello everyone, welcome to my channel Vidyarthini's Academy of Computer Science, Learn with Passion. In today's video lecture, we'll be learning about CPU scheduling criteria. That is, we have many CPU scheduling algorithms, and in order to decide which algorithm is suitable for our requirement, we need to have understanding about the CPU scheduling criteria, and this is what we are going to see in this video lecture, so that we can compare between different scheduling algorithms and decide which is the scheduling algorithm that we are going to follow. And before we get started, if you like my video lecture, please do like, share and subscribe to my channel, and don't forget to press the bell icon. And now let's get started. In this video lecture, we are seeing about CPU scheduling criteria, and these are the topics that we have covered so far under first unit, and now we are in CPU scheduling criteria. There are five main CPU scheduling criteria based on which we are going to select the algorithms, and this five different scheduling criteria help us to determine the efficiency of particular scheduling algorithm. Okay, the first one is CPU utilization. In CPU utilization, what they are expecting is they want the CPU to be utilized at the max. So that is what they have given. We want to keep the CPU as busy as possible. Conceptually, CPU utilization can range from 0 to 100%. We want to keep the CPU as busy as possible, which means that some process or the other should be always getting executed from the CPU, and the CPU should be utilized to the maximum. We don't want the CPU to be idle at all. We want the maximum work should be done by the CPU. We don't want the CPU to be idle. That is what CPU utilization, and conceptually they are saying that it should range from 0 to 100%, but whereas in real-time system it should range from 40% for a lightly loaded system and to 90% for a heavily loaded system. That is, minimum for a lightly loaded system it should make use of the CPU at least 40%, and for a heavily loaded system it should be 90% of the CPU should be utilized. So this is what is CPU utilization, which means that we have to get the maximum utilization of the CPU. That is what they may mean by CPU utilization. And the next is throughput. If the CPU is busy executing processes, then work is being done. See, when they say CPU is busy, it means that some process or the other is making use of the CPU. And one measure of work is the number of processes that are completed per unit, called the throughput. So throughput is basically the number of works done by the CPU. So when there is a maximum utilization of the CPU, then it means all the work is done by the CPU. And when all the work is done by the CPU is always busy. When CPU is busy, it means that we are getting maximum work done by the CPU. So how do we measure the work done by the CPU? One way of measuring the work done by the CPU is the throughput, which means that it is the number of processes that are completed per unit time, which is called the throughput. So per unit time, how much work is getting completed, that is the measure we have, and we call that as throughput. All right. So this criteria called per unit time, how much work is done, that is what we keep it as a measure in order to calculate CPU utilization, and this is what we call it as throughput, which means if the CPU is busy processing the work, it means the work is being done, and one measure of work is the number of processes that are completed per unit time, which is called the throughput. All right. The third criteria is the turnaround time, and that is, we saw about throughput. Throughput is the one which we see from the CPU point of view. That is how well or how much we are using the CPU. That is getting maximum utilization from the CPU, and how well CPU is getting used per unit time. That is what is throughput. Whereas turnaround time is from the point of view of a particular process. So this is what given from the point of view of a particular process. The important criteria is how long it takes to execute the process. That is, execute the process in the sense from the time the process is ready, and from the time the first thing is from the time the process is ready, and the time when it gets into the ready queue and when it is getting executed by the CPU, and finally the time for IO operation, and lastly when the process is getting completed. So the interval from the time of submission of the process to the time of completion is the turnaround time. So from the time of submitting a process, so when we talk about turnaround time is the thing which we are talking from the point of view of a process, from the time the process is ready till the process is getting completed. So how long it takes, this is one criteria for selecting the scheduling algorithm. So we have already seen about the states of processes, and how much time it takes for all the states to be completed is what we are seeing in the turnaround time. That is, if the process will have the state of when it is ready to get into the ready queue, and when it is waiting in the ready queue for making use of the CPU, and how long it is getting processed in the CPU, and how long there might be some processes which will require input-output processing to be done. So how much time it takes to do the IO operations, and how and when the CPU is completing the process, and finally the process is getting completed. So the interval from the time of submitting the process to the time of process is completed is called turnaround time. So this is from the point of view of the process, and throughput is from the point of view of the CPU, and turnaround time is from the point of view of the process. All right. So turnaround time is the sum of period spent waiting to get into the memory, and waiting in the ready queue, executing on the CPU, and doing the IO operation. So that is what is called as turnaround time. All right. Next is the waiting time. CPU scheduling algorithm does not affect the amount of time during which a process executes or does IO operation. That is, the scheduler is not concerned about how long the process is using the CPU or how long it is doing IO operation. It all depends upon how big the process is, or how the process is getting programmed. The CPU scheduler is concerned only about how long the process is waiting in the ready queue. That is, how long it is ready to get, it is ready to work, but it is waiting in the ready queue because CPU is being used by some other process, or because some IO operation is getting processed. So the process is waiting in the ready queue. The time that the process spends waiting in the ready queue is called the waiting time. It only that is, the second point is, it affects only the amount of time that a process spends waiting in the ready queue. So the scheduler is concerned only about how long a process is waiting in the ready queue, because using the CPU depends upon how big the process is, or how well it is. It requires the CPU, and what are the IO operations it is involved in it. So the scheduler is not concerned about all that. It is concerned only about how long the process is waiting in a ready state in the ready queue. So waiting time is the sum of the period spent waiting in the ready queue. So this is very important criteria, because we have to choose a scheduling algorithm based on how effectively it assigns a process immediately when the process is ready to work. So this is what is a very important point, because when a process is ready but it is spending a lot of time in the waiting queue, I mean in the ready queue, just because it is not getting the CPU, or there are IO operations to be performed, and it is always waiting in the ready queue, means then we have to choose a better scheduling algorithm. So the scheduler is always concerned about how long a process is waiting in the ready queue, and it should be minimized. The waiting time of a process should be less, in such a way that we have to choose a scheduling algorithm. So immediately when a process is ready to work, it should get the CPU, that is, it should be able to get processed. So there must be less waiting time. That is one of the very important criteria, that is waiting time. So finally, the CPU scheduling algorithm does not affect the amount of time during which a process executes or does IO operation. So scheduler is not at all affected by CPU utilization or IO operation. It is affected only by the time that the process spends waiting in the ready queue. Okay, all right. So next criteria in CPU scheduling criteria is the response time. In an interactive system, turnaround time may not be the best criteria. What is turnaround time? Turnaround time is the time the process is ready, executed, and produces the output. Whereas in an interactive system, the single process may be required to produce multiple outputs. So once the output is produced, it doesn't mean the process is completed. It might require multiple outputs to be produced. So in that case, we go for response time. So the second point is, often a process can produce some output fairly early and can continue computing new results while previous results are being output to the user. So that is what, once the output is produced, it might undergo some other computation to produce some other output. So that in that case, thus another measure is the time from the submission of a request until the first response is produced. So here they are using the response time, that is, once the request is placed, how long the scheduler takes to respond. That is the time between the request and the first response to that request. That is what is called as response time. That is, this measure is called response time. This measure is called the response time. It is the time it takes to start responding, and not the time it takes to output the result. So here output of the result is not considered. It is the time it takes to respond to the first request. That is, once the request is placed, how long it takes to give the first response. That is what is called as response time. The turnaround time is generally limited by the speed of the output device. Okay, for example, there are video files in our system, right? When we double click the video file, it takes 1 or 2 seconds to open the video file, or it might even take a fraction of seconds. So it takes some amount of time in order to start the video file, that is, in order to respond. So that is what is called as response time. I am placing a request, that is, I'm double clicking it, that is what is the request, and it takes 1 or 2 seconds, or it might take fraction of second to respond, that is, open the video file. So this is what is called as response time. So when in case of interactive system, interactive environment, this type of response time will be the criteria in order to choose the particular scheduling algorithm. All right, so these are the criteria which we have to keep in mind when we are choosing a scheduling algorithm. All right, and thus, thank you. In my next session, I'll be talking about scheduling algorithms. What are there are many scheduling algorithms. We'll be seeing one by one in my next video lecture. Thank you, and And if you like my video lecture, please do like, share and subscribe to my channel, and don't forget to press the bell icon. We are now available in our socials, Instagram and Facebook. Do follow us and do support us. Thank you.